start our global presentations tonight, I get the honor to introduce my professor, Dr. Bill MITSCH. So I decided I'd say some really nice things, and hopefully he'll let me graduate. So, Dr. Bill MITSCH has been a university professor who specializes in wetland and aquatic biogeochemistry and ecological engineers at 4 different universities for the last 44 years. In that time, he has advised to completion with either theses or dissertations 79 graduate students and 13 postdoc students. Most of them work at the Ohio State University, but currently he's advising 3 PhD students and 1 master's student down here at Florida Gulf Coast and the University of South Florida. He is an Eminent Scholar and Director here at the Everglades Wetland Research Park. He's the Juliet C. Sproul Chair for Southwest Florida Habitat Restoration at Florida Gulf Coast University in Naples, and has been here since 2012. So, without further ado, Dr. MITSCH is going to come up and talk about sustainably solving legacy phosphorus in landscapes with wetlands and wetlaculture.
Okay, I'm going to use that one. All right. Testing, can you hear me? Yes. All right, well, thank you. That's an honor to be introduced by your graduate student. She's right, she hasn't graduated yet, but she did okay. I'm going to talk about wetlands and harmful algal blooms sort of intermixed, and it will get into the wetlaculture term that you had heard earlier. Let's see where we're going. Well, I'm going backwards. The one compelling thing that has me wanting to build lots and lots of wetlands is the fact that we basically trashed our planet and got rid of most of our wetlands. There have been all sorts of studies that have suggested that we've lost half of our wetlands in the 20th century, that we lost long-term 50% of wetlands of the world relatively recently. And this one was a shocker to me. I don't know who did this study, but they suggested over the last 300 years, the world has lost 87% of its wetlands. And that, you know, when we lose that kind of, we lose a resource like wetlands that we've determined to be among the best ecosystems on the planet, there's something wrong, and we got to correct that. So that's one thing that compels me to want to put wetlands back, is just to make up for all these earlier sins. But there are many opportunities to what I call ecologically engineer, with small e's, reversal of the global loss of wetlands, at the same time mitigate in a sustainable way some of the most alarming pollution problems on our landscapes related to, I say, phosphorus and nitrogen, and I also say carbon here, although I'm not going to talk about carbon in my talk very much. But let's go straight to the Florida Everglades. You guys have seen these diagrams countless places. There's a very nice display of them at Corkscrew Swamp, for example. The left is the historic river of grass with a flow from north to south through Lake Okeechobee, and the river of grass below that. Then the second graphic shows the mess that we currently have, where we have too much water going the wrong places. We shunt an enormous quantity of polluted water east and west to our coastlines, and we all know about that. We experienced it right here in Fort Myers, Naples. And the last diagram suggests what we want to try to do is to get back to some norm and have a lot of the water going north-south again and not east-west. So that's the plan. We're not anywhere closer to that right-hand graph than we were 20 years ago. We still have basically what you see in that diagram in the middle. The water is being wasted to our 2 coastlines. It's being wasted, but it's also trashing our 2 coastlines. I think a lot of us remember, and I think Daniel on the panel that just ended, Daniel Andrews, we all remember where we were when this plume of dirty water came down the Caloosahatchee River in late January, early February of 2016. It looked so awful. I mean, that looks like it's a parking lot, and it's not. That's the water coming out of Lake Okeechobee down the Caloosahatchee, and that's as it's entering the Gulf of Mexico. Could we turn the lights down, maybe? I don't know if that'll help. And it was approximately 3 billion cubic meters, or if you want to say cubic yards, of polluted Lake Okeechobee water, came down the Caloosahatchee to the Gulf and the St. Lucie on the east coast to the Atlantic, well, it was to the Gulf, and St. Lucie was to the Atlantic Ocean in 2016, severely polluting both estuaries. The pumping of the water was deemed necessary by the Army Corps of Engineers to reduce unsafe Lake Okeechobee water levels, which were in turn due to the high rainfall in January of 2016. That was really the beginning of the modern era of water quality concerns in this part of the country, and it still remains. And what happened after a lot of, I'm a professor and I work down here 8 or 9 months of the year, so I am an academic snowbird too, so I go north for the summer. And while we were up north, a few months after that is when these gigantic algal blooms occurred on both coastlines, and the governor had to declare blue-green algal blooms emergencies on both sides of the state. And that's just that's a secondary effect of that, what you saw, the dirty water coming in January and February. Then in 2018, it really got messy, and that's when we had outbreaks of red tide, especially up in the Fort Myers area and north all the way to Sarasota and even Tampa Bay. And it was just, the governor had declared emergencies for freshwater blue-green algae and coastal red tide algal blooms. The governor's getting quite an education when these things are happening, because he probably didn't know the difference. But this was one of this particular pollution time, and we were out on the water, there I was, taking samples, and I've never, ever seen the environment so trashed in my life as that episode. I've been around for a long time, and it was just a mess. You can see what I have in that Van Dorn sampler, the brownish color, that's the red tide after it's spent some of its time already and it's lysed. But it was really just an awful situation. And by the way, on that particular boat trip, I was with Daniel and the friends of the captains. Yes, I'm trying to think what they're called. The captains for clean water kindly allowed us to use their boat, and that's why we were out there. And the captain actually told me he was sick for 3 months after that trip. Well, we took those samples, and I just want to show you a little bit of what we learned from that trip, since everybody wants to know red tide, what's it doing, and we were doing a study that was just sort of fell in our lap on isotopes. And I don't want to get into a detailed discussion of isotopes, but I'll try to walk you through it. But you can see where we sampled, and it was a 2-day event. First day we went out with the people from FGCU, and the second day we went out with the captains. And when we went way 20 miles off coast, like you can see in that first sample, there was no red tide cells whatsoever. It was clean water. And as we worked our way in towards Sanibel Island and the Caloosahatchee, you can see you go from medium to high. High means really high counts of red tide algae. And that was over August 8th to 9th. So most of the bad water was right in that area between Sanibel and the coastline and where the Caloosahatchee came in. That was the hot spot. The amount of nitrogen in samples out in the open water was relatively low. The river average was relatively high. I mean, these aren't exhaustively high, but these are high enough to cause trouble. And then the nitrate in the red tide area, where we were actually sampling red tide, was fairly high too. And the isotopic analysis basically is a way that you can trace the source of where that water comes from, for lack of a better way to say. It's sort of CSI water quality kind of stuff. And the isotope signal for nitrogen compounds has proven to be a viable tool to identify sources of nitrogen pollution. So that's what we were doing. We were also had different, well, with the isotope of nitrate, NO3, you have N has an isotope that we sometimes find in rare amounts called N15, and O has an isotope, oxygen 18. Very small concentrations relative to the normal isotope, but nevertheless that tells us something. So this is a model that has been published for a number of years that suggests if you put a data point on this thing with the x-axis, no, the y-axis is the delta or the isotope of oxygen. I'm trying to read it from an angle. And the one on the x-axis is nitrogen. Okay, so because nitrate has two isotopes, you can identify where the water is coming from. And they've developed this graph that suggests, I recolored it to make it very clear, where the data point falls on this graph tells you where the water came from. So this is their data points. See those dots? They represent the average of the isotopes for those two, or for the nitrogen and the oxygen isotopes. And what you can see is, for example, out where we were sampling, the Gulf of Mexico with no red tide, the small amounts of nitrate that were there were called marine nitrate. And that's what it fell exactly where we thought it should find. In other words, the nitrate that may be causing some red tide, but not very much, in the marine areas comes from the sediments. It comes from marine sediments. And we've known that for years, that red tide starts via upwellings, maybe sometimes after a hurricane. And then but what happens is it gets intersected with water coming down the Caloosahatchee or whatever, and just gets walloped with what we're calling, and what that box says, you can't read it because of the dot, it's called nitrate fertilizer. So the signal we got right in the middle of that red tide, where you saw me, where I was taking that sample and my eyes were weeping from all the nauseous smells and so on, that's our smoking gun that CNN wanted when they were on our boat. They wanted us to nail sugar or nail Okeechobee or whatever. Well, we didn't, but what we did find out is that the fertilizer is what was causing the big red tide just off the coastline of Fort Myers Beach. It was a horrid red tide. And so that's something that we found that should be taken note. And when we publish this, and not until we publish it, we should look again at what are the causes of red tide and what we're saying with our limited sampling. You know, red tide doesn't come in when you're sampling, it comes in when you're not sampling. And so we just happened to catch a moment where we identified the source of red tide as nitrate fertilizer. So that was one point. The second point, and it didn't match, is that we did not match the signal from either Lake Okeechobee or the Caloosahatchee River. They weren't the same as the nitrate in that red tide. So we could not say, this is what CNN really wanted us to say, we could not say that the Lake Okeechobee is connected to the red tide. It would have been too convenient if those dots had fallen in the same, but they're not. So I guess what we're saying is we found something that's interesting. We should think anew about nitrate fertilizer. The only two places it comes from is urban fertilizer for golf courses or backyards, and agricultural fertilizer that's used in plentiful quantities throughout South Florida. So in other words, what I'm saying, and when people say, well, let's study manure and septic tanks and blah, 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 let's focus on nitrate now and see if that's really the main cause. That's what we're saying it was on that particular day, or those 2 days. So I've just put that in as a little background that, first of all, nitrogen, nitrate, is very, very important chemical to deal with if you're dealing with coastal waters. If you're in basically salt water, which is what red tide is. It's a saltwater pollution. So it's not all about phosphorus. Phosphorus is more fresh water. So solving harmful algal pollution with wetlands, you heard Chancey Goss talking about the STAs. I don't know if any of you click when you hear that term. I don't like it that they called wetlands STAs. I'm a wetland scientist. Call them a wetland, damn it. But their lawyers wouldn't let them do it. Do you guys know this? They were not allowed to call these wetlands wetlands because the lawyers were afraid that the Clean Water Act, the federal government would come in and call them a federal wetland and shut them down or whatever. So they were told not to call them wetlands. Now, I think that's been relaxed a little bit, at least I hope so. But I call them wetlands, or treatment wetlands. And you've heard them mentioned several times that there are 57,000 acres of these wetlands. It's not a trivial number, 57,000 acres cleaning especially phosphorus out of the water. There's no place in the world that built 57,000 acres to clean water. We've got the absolute biggest wetlands for cleaning up water of any place on the planet. You know, when I go to other countries and tell them we have 57,000 acres cleaning water, they say, what? Is that the whole country? No, it's South Florida. It's an enormous accomplishment, and I know the people that designed it and built them, and they were taking a chance because the chemical industry wanted to build chemical treatment plants to solve the problems, and these work. This is what they look like. Looks like a wetland to you, right? It sure does to me. No, STA. And even where you see the blue water, open water, there's plants under that water. They're called submerged aquatics. And so these are functioning systems, and they work, and they're well designed. I think the district gets an A++ on this one of building them and maintaining them. These are some data over the history of these STAs, but I'll focus just on the last couple. The orange, by the way, is the outflow of the STAs, sort of averaged, and the blue is the inflow of total phosphorus. Total phosphorus. And the units you can't see, but they're in parts per billion. So I'll give you a couple examples of recent years. 2015, the inflow of total phosphorus was about 100, 99 parts per billion in the inflow and about 17 outflow. 2016, 143 parts per billion inflow, 20 in the outflow. 2017, 94 in and 15 out. They're working, ladies and gentlemen. They're working very well. And I think the district deserves some credit for this. So we're going to talk, well, except here's the fly in the ointment. The federal government decided on their own that they would have a separate standard of 10, so even all these numbers that I gave you here, they're not good enough. And it's just like that commercial they have now. Not good enough is not good enough. And so we should try, 10 is easy to remember also. So 10 parts per billion is the standard to the Miccosukees, to the Gators, and to everybody else, but not to the agencies. And so it's just an easy standard to remember, but we're darn close. When we're down to 17, 15 parts per billion, that's very close to this magic number of 10. So those wetlands in Florida show that you can build enormous areas of, I don't want to call them artificial wetlands at all. There's nothing artificial about them, but they are man-made wetlands, but they become real wetlands after nature has, after we build them and say, nature, you take over, and they become real wetlands. And the birds, by the way, just absolutely love them. That was one of the surprises that the district found after they built these SDAs and they wanted to keep them secret from the EPA. Well, they couldn't keep them secret from the birds. And it's some of the best birding locations in Florida now. So in the meantime, so that's an area thing. These are the kidney-shaped wetlands that I built at Ohio State University. They became known as OSU's kidneys. And they're still there. And so what we had there was many years of data, year after year measuring it. And we came up with some very tight numbers of how much that's phosphorus is retained in the wetlands and how much nitrogen is retained in the and I tell my students, you can take these numbers to the bank because they're based on 15 years of studies, and they tell us what a wetland will normally do as long as you're not over polluting it as far as removing nitrogen and phosphorus. So, and that's based on many years, I said. So we got projects that have measured these nutrients over many years, and we've got projects that are measured over very large areas. Now, that takes me to the latest thing that people are proposing to save our coastlines and so on. And you heard, let's see, who talked about this? The EAA reservoir. That was probably Jacqueline. Yeah, from Sierra Club. Yeah, and they don't like it one bit, and I don't blame them. This is the EAA reservoir proposal. I'm going to summarize, and you can see there's a couple little squares down there. One is a reservoir, one is some kind of water storage system. And you can see it's about 30 miles south of Lake Okeechobee. So all they're going to be doing is first of all, what they're going to be doing is pumping or allowing by gravity water to go south to this reservoir from Lake Okeechobee. So basically they're just building another little Lake Okeechobee. If you take Lake Okeechobee water and put it in a hole in the ground, what are you going to get? Another Lake Okeechobee, only 30 miles closer to the Everglades. So that's one issue with it. And it's a lot of water they're going to be putting down there, increasing the flow from north to south by 76%. So there's going to be just water gushing to the south. It's supposed to be intercepted by a 10,000 acre reservoir that you heard that was discussed earlier. And it's 23 feet deep or 8 meters deep. There is no such thing in the Everglades as anything 8 feet deep. So this is not restoration, and I think you heard that very loud and clear from the panel earlier. And only 6,500 acres of treatment wetlands or STAs or whatever you want to call them. Now remember, this is a technology that they have refined. They are good at it. Why the only 6,000? Because sugar wouldn't get them any money or any land. Sugar wouldn't give them any land. And of course, we had a governor at that time, this was before our current governor, who wasn't going to push them for anything. So basically, they had to work within all the public land that was left in that little corner that you see there. All the rest is sugar farms. So that's why the 6,500 is such a small number. It's only a 13% increase, and you have yet a 76% increase in flow. Those don't match at all. So therefore, I have concluded, and I did a study of it and published it, as designed, this EAA reservoir project will likely deliver phosphorus-contaminated water to the Florida Everglades. So there we are. We're going to trash the Everglades so that we don't have trashed beaches. That's a terrible choice, by the way. We're being forced into that situation. And it's a very, very politically charged project. You know, I could lose my job by giving this talk. That's the kind of political charge it is. When you criticize this, you're walking on shells. But I'm absolutely sure it won't work. Anyhow, and this is the paper we published in August, last August, Restoring the Florida Everglades, Comments on the Current Reservoir Plan for Solving Harmful Algal Blooms and Restoring the Florida Everglades. It is not a restoration project, ladies and gentlemen, not even close. And it probably is going to trash the Florida Everglades forever if we add phosphorus water down there. So I went public after I published the paper, and boy, oh boy, every newspaper in in Florida picked up this story for about 2 days, and then all the stories disappeared. There's some force there that I don't understand, but it's just not going to work. And by the way, not surprisingly, the Sierra Club, who was up on the table earlier, absolutely agrees with me. So it was all over the place. The TC Palm was the first place. And then I was on WGCN, or WGCU, sorry, our public radio station here. And it says, wetland scientists question the design of the EA reservoir project. So that's where we are now. There's a few of us that are questioning it, but the bulk of the news coverage, the bulk of the chatter, the bulk of everything you read about this thing is this is going to be a good thing for the Everglades. Let's build it, and let's build it now. I disagree strongly. It's going to be a dumb thing. I'll get to the questions.
Have you passed your article around to the national media?
To the national media?
Yeah, maybe somebody there would pick it up.
I don't think they would understand. The national media just doesn't understand what we're doing down here sometimes. No, I mean, it's not like I'm handing papers out on the street corner. I publish things, and if it gets out,
I'll pick it up for you.
yeah, you send it to them, sure. But this was already published in August of last year. So, and it puts me in a very uncomfortable position. I wish I didn't have to say this. I wish I could say, yeah, this is a great project. Governor, get that money from Trump as soon as you can, and let's build it in record time. And I can't, and I won't. So that's sort of the sad part of what's going on now, of all this restoration talk and fixing the Everglades and so on, is that we might be actually going towards an absolute trashing of that Everglades with excessive phosphorus coming from Lake Okeechobee. They've just got to redesign it. That's all there is to it. So that leads me to this idea of wetlaculture, which is separate from everything I've shown you. It's sort of a compromise idea of fixing a landscape and having wetlands and agriculture in sort of harmony, if that's the way to say it, or at least in a standoff or something like that, maybe. But you have to follow my logic, and I hope I don't confuse you. This all started with the Everglades. You guys have heard of the Everglades Foundation. In 2014, I remember it well, they all of a sudden announced, they didn't call it the George Barley Prize then, but they announced a big prize that's available. It was a $10 million prize for a proposed innovation that would do the following: remove phosphorus from water and landscapes. They weren't very much more specific than that. Return that phosphorus to human society, so recycle it somehow. So it wasn't enough to build something that took phosphorus out of the water. You'd have to recycle that back to society. Later, and this is very significant, and you'll understand why we did the study in different states. Later, a stipulation was added that the innovation would work in cold climates. Now think about this. This is Everglades Foundation. They're in Florida. Everybody in Florida is not from Florida. They're all from the Great Lakes or the East Coast or whatever. They all have their own pollution problems. So I am sure what happened is one of these rich people who they were trying to get a lot of money from said, well, now, will this, whoever wins this prize, now, will the winner, will the prize that wins, will that help Lake Erie or Lake Champlain or whatever lake these people knew about? And they thought about it a second, but probably didn't think it through. Well, yes, of course. And so they added this thing about requiring cold climates as another criteria for who would win this $10 million prize. And what I'm going to show you is the project that we think we should have won this prize on, and it's 2020, and this is when they're supposed to announce it anyhow. So yes, you can give me an applause at the end, but I won't get $10 million. But here's the basic idea. The top graph shows what we do right now. We basically have a fertilizer industry that dumps nutrients. The dark lines are nutrients. Nutrients on agriculture, that goes via the food source to human economy. Human economy and agriculture dump excess nutrients into lakes, rivers, and estuaries and trash them. It's a one-way street. It goes from the fertilizer industry to the lakes, rivers, and that's where it ends. And you know, eventually goes out in the ocean in most cases. What we're saying is the following. It's the diagram on the bottom. That we have the agriculture still on fertilizer industry at first, but we take some of that waste from the agriculture that's otherwise going to the lakes, rivers, and estuaries and divert it to a treatment wetland that's nearby. Then we'll show you how we do this. It's so simple, it's ridiculous. We reroute those nutrients from that treatment wetland back to agriculture, thereby recycling the nutrients, and thereby, this is the most important graphic I'm going to show you, cutting off the nutrient aorta. I don't know what it is. That's the cause, that we're just putting fertilizer on the land every year, no matter what. And it's almost the most sacred tenet of agriculture. They will not let you touch their phosphorus. The other one is they don't like you to mess with their hydrology, but they won't let you touch. And so there's never been a regulation about fertilizer use on farms, ever. Isn't that ironic? I mean, so what we're talking about is designing a system that will recycle the nutrients within the landscape and allow us to at least cut off a major supply of nutrients from the fertilizer industry. And we do it, we're doing our experiments in these little tubs. They're called mesocosms. And these are basically our idea of, there are test tubes. When you study wetlands, you can't use real test tubes. I admire lots of microbiologists that do their whole career with test tubes in their lab. We can't do that because the plants won't fit in a little test tube. You know, the mud won't fit in there. You need a little bit bigger thing. So these are usually 100-gallon tubs that each represent a wetland. And we're able to do experiments and do all sorts of replication of experiments and the like. So our normal design for the ones I'm going to show you is 28 tubs, and I'll have to explain why it's 28, but it's, we're also doing some hydrologic experiments, and we're doing those so that my graduate students can get their degrees. If I just gave them a bunch of tubs, they were all the same, you know, what's the point? So we put a little hydrologic experiment in it as well. And because we had heard there was a rumor that they were going to require northern sites, I'm up like any good snowbird professor. I was up in Ohio that summer, and we started looking around for a couple sites where we could run this experiment in Ohio, because we wanted a cold climate site. And we found one in Buckeye Lake, which is very near central Ohio, very close to Columbus. And then we found another one at Black Swamp area. We'll talk about that in a minute. And then finally, we were able to work with Collier County and build one at Freedom Park in Naples. And it's up and running, and you can go see it. It's got a fence around it to keep the dogs out, but otherwise it's an example of this experiment right down in Naples. And this has a lot of details about it, and what plants we planted and what crop we might use and so on and so forth. But this is what they look like. These are the wetlaculture mesocosms at Buckeye Lake that were created in 2016 and 17. We decided to have an open house there, and my God, 100 people showed up. And it was just 28 tubs in the ground. And we had trouble making it a wow project. But it was a very attentive group. They really liked what we were doing. And they thought that if we instituted this, that the Buckeye Lake would be clean once again forever. And it's not that easy. Again, these are small-scale studies that would have to be ramped up to big scale to work. Then we went up to northwest Ohio, and we're very close to Lake Erie. We built another set. And see the corn in the background? This is just productive corn like crazy. And so that was constructed in 2017-18. And this is where it was built. You can see where's my pointer? It's right here on the edge of what used to be called the Great Black Swamp, which was the western extension of Lake Erie. Great Black Swamp does not exist anymore. It was totally 100% drained. You can tell when you drive through that area, it looks strange. It's flat, and everybody's, well, what's going on here? Well, historically, the Great Black Swamp is gone, except for a few remnants that are around. And it was a swamp. It was a forested area. It was considered the most despicable place on the planet to the people who lived up there. And so for years, they've been very proud that they drained this, and what we're suggesting, hey, let's put a little bit back. And you can imagine when I drive through Toledo, I have to be a little careful. Although I think now the people in Toledo would appreciate the fact that bring back the wetlands to clean the water. So it was a 1 million acre wetland of marshes and swamp forests, mostly swamp forests, and that's why it was so impenetrable. They didn't put highways through there, they put corduroy roads. Has anybody ever heard of corduroy roads? Yeah, we got one person. Basically, you chop down all the trees, put them sideways, and you drive through the landscape on top of trees. It takes a lot of trees to do that, but in the swamp, there were plenty of them there. So it was totally drained in the early 19th century. And so now we're starting to talk about partial restoration to fix Lake Erie, which you can see just on the right there. And the third site, these are the latest, constructed in 2018, are the wetlaculture mesocosms in Freedom Park in Naples. You guys know where Freedom Park is? Yeah, it's right smack dab in the middle of Naples. And so we put a fence around this one because a lot of people walk their dogs, and we don't want our nitrogen budget to change. And there, it's located in that upper northwest corner of Freedom Park, in case you ever visit there. It's a great, interesting place because I think I don't know of any place that's so glamorized, in a sense, the ability of wetlands to clean up water. I just wish that they would tell it better to the public. But anyhow, it's a very interesting place. These big wetlands are working, and we've done several studies for Collier County on them. But I want to show you at least one bit of data, and my other graduate student, Bingbing Jiang, will tomorrow present details of one of these 3 wetland sites. But the 2 on the left, all you have to do is look at the colors and look at the high bars, are really, really working well in Ohio, taking nutrients out for nitrogen and phosphorus. You can't read the small print, but it's several species of nitrogen, several species of phosphorus. The one in Florida on the right is just driving us mad with what the data is showing us so far. It's showing with the bars below that these are exporting. Bing, you're going to have to help me, I can't read it. It's exporting phosphorus, total phosphorus, and soluble reactive phosphorus, I believe. And you think, wait a minute, exporting phosphorus, what's going on here? Well, we did some studies, we looked at some possibilities, and then we had one of those aha moments where we realized that Freedom Park, they have spray irrigation, and have had it forever. So the site that we chose for our mesocosms had been sprayed by irrigation water. You know where that comes from, treatment plants. In other words, high nutrient water. And so the soil, especially the sandy soil, was just loaded with phosphorus. And so what we're doing is, as we continue to add polluted water, but not nearly as polluted as that, we're exporting more phosphorus out of those tubs than is there. So it'll take a couple years for them to become sinks, is what we're saying. But we had never thought about that. So all of a sudden we got one of those aha moments like, does the government know they're polluting the landscape with those recycling things? We drive through them all the time, right? When you develop, you see, well, why it's all this water on the street? Oh yeah, it's the sprinklers. Those could be causing red tide and all sorts of other things. They could be the main cause. I'm not saying they are, but they could be. So the graduate student who's working on this one, he all of a sudden got a new chapter in his dissertation, and that is to follow this and see. So he's capturing sprinkler water all the time now, and we're going to see if that's a significant source of nutrients for our experiment. But more importantly, are we really trashing the trashing the coastline with all that water? Yes.
Are you talking about gray water or potable water?
Well, it's not potable, it's gray water.
Okay, so everybody uses gray water in Colorado, I think.
Right. And what's the grade? You know what it is? From a treatment plant.
Yeah, I understand what it is. That's fine.
From secondarily treated wastewater, it's mostly nitrogen and phosphorus water.
Right, I knew that. And
Okay.
Colliers said don't use fertilizer if you have that.
How what?
Colliers, haven't they been encouraging us not to use additional fertilizer?
Well, I mean, why do you need the fertilizer to begin with? But that's one
Right,
question.
I agree with that, but you don't need additional for sure. I didn't realize that it was actually causing the problem.
It could be. All I'm saying is we wouldn't have found that except we were doing this experiment. It has nothing to do with wetlaculture per se, but it surprised us. I mean, that's what happens in science sometimes. You find things you aren't prepared for. Okay, well, anyhow, I'm flipping on to the mesocosms. Our idea of flipping mesocosms is that after we have them as wetlands, and that's what we gave you the data, that their wetlands are taking nutrients out of the water very well, that we flip them, not rotate, I don't like that term. We flip them, flip is cool, you know, we flip properties and stuff like that. We flip them to agriculture by doing two things, turning off or pulling the plug and making them non-wetlands, if you will, and putting 2 or 3 corn seeds or sugar seed. Are there sugar seeds? I don't know, maybe. But, you know, in other words, planting them with agriculture crop after we dry them down. And we see if the crop grows with what we've captured by the wetlands. Now, we're going to do that with a graduate student. Where's Kyle? I didn't want to tell him this, but I think he's going to be doing the flipping in April at a couple of these wetlands or mesocosm areas. And you know what my prediction is? The plants won't grow very well. But we're doing it for you, because you want to get your degree done in 2 years. Otherwise, we'd wait 5. So anyhow, but no worry, there's more graduate students after him. No. I said that in a very positive way. He will publish his results. You know, you don't always have to have positive results of everything. Results are results. And I'm predicting he will show that the corn don't grow very well. I'll be delighted if it does grow well, but I'm just saying we'll give you a degree either way. Okay, so we're going to start flipping this spring at a couple of the sites in Ohio. Maybe not in the Florida one, I haven't decided on that. And just see if the crop that replaces the wetland plants grows well without additional fertilizer. If it does, oh my God, well, you know, it'll be a big story. But I feel like they need a few more years of wetlands before they're ready to really have spectacular growth. But I could be wrong. So what we're determining is X number of years as a wetland will produce Y number of years of sustainable agriculture. X and Y are unknown. That's why I consider this to be a 10-year experiment. And that's why I tell my graduate students, you're not going to see the end of this experiment. We'll give you a degree when you got a couple years of data. Yeah?
So, Phil, at the end of the Y years, would you then be returning that to the mesocosm and start processing?
Well, to the wetland, you mean? Yeah.
Yeah. So if you go
right.
from X to Y.
So we think a 10-year experiment, which we're basically 2.5 years into a 10-year experiment, a 10-year experiment, we should be able to get some inkling of whether this flipping works at an early stage. But I may be wrong. We maybe need 20 years. I don't know. But what we want to do more, because this is telling us a lot when we're getting these data, I'm looking for a happy farmer that can give us, oh, I don't know, what are we talking about, 100 acres? Something like that. And by happy, I mean really interested in doing something novel with their land, and we will pay them. We will pay them better than they would get from the crop that they would grow. What's wrong with that? So what we're saying is the farmers should be paid for growing clean water as well as clean corn or clean sugar. And you know what? If you went down the street and asked somebody along the street, or asked 100 people on the street, what do you want, clean water or clean corn? I would bet 98 would say clean water. I mean, I'm joking about the clean corn, but you know, I think it. And plus, if the farmer's smart and they like our brand and they say this was grown by wetlaculture brand or something, you know, they might be able to charge twice as much for the crop too. I mean, that's sort of what's going on now anyhow. So we're sort of in the middle of this long-term experiment. I just wanted to give you an update on it. As I said, my graduate student Tamara Bingbing will give more details on the one up on Lake Erie, because that's such a hot spot. We want to make sure that one works too. So a wetlaculture landscape, a reasonable landscape, could be thousands of acres of wetlands for 10 years, then flip to agriculture for 5 years, and then flip back to wetlands and so on. So it will be a dynamic landscape. Advantages: no fertilizers needed, so you're spiraling down the legacy nutrients in the landscape. Improved water quality every year for downstream aquatic ecosystems, and the wetland providing ecosystem service and farms providing foods sustainably with a sustainability badge on it or something if they want. This, and then so everybody says, for years they'd say, well, what would a landscape look like? That's why this picture that you've seen now up on the screen many times, and probably will see many more. I worked with my artist. She's helped me do all the wetland textbooks. And I said, we got to draw a wetlaculture landscape, what it would look like to a duck who's flying back after the winter or the summer or whatever. And so we came up with this, and I don't even know which ones would be crops and which ones would be wetlands. That's immaterial. There would be different land uses. And the poor duck, if we flipped one of his or her wetlands to agriculture, it'd be okay, because the duck would say, oh, there's another one right next door. That's fine. So we're not going to torture the ducks. But it really would be, I mean, you can always be attractive with the colored pens, but it would really be an interesting looking landscape, and not the monocultures that we have now. So, and I'm going to not take any of your thunder, Sam, but Sam Miller is here, and he's giving the second talk as soon as I get out of here. Am I over time, or Ernie? I am?
You're at an hour.
What?
You're at an hour.
Really? Sorry, Sam. Well, Sam, you can talk about this. This is the business model Sam Miller and I have been working on that goes far beyond the nitrogen and phosphorus talk that I just gave you. It's actually a business model that might work. Sam tells a great story, so I'll give up the microphone here in a second as soon as I finish. So my conclusions are, can we dim the lights for these? Restored or created wetlands can remove significant amounts of nitrogen and phosphorus in agriculture and stormwater runoff at large scales, and I'm really at an angle here. Also significant sinks of atmospheric carbon, which we didn't talk about, but there's also a sink for carbon and can be part of that equation too. In the Florida Everglades, the pollution of the east-west coastal estuaries by Lake Okeechobee water has to stop, period. Well, there's not a period there, but I could say it. And the original north-south flow of the greater Everglades must be achieved but only with clean water. That's my stipulation. We estimate that an additional 100,000 acres of created and restored wetlands need to be added to the current plan to protect Florida's coastline from blue-green algae and red tide and allow the excess waters to flow south to the Everglades. So we're saying 100,000 acres is a rough approximation. It's got a safety factor of 2, so I calculated it to be 50,000, but anything ecological, you better put a safety factor, so we've rounded off at 100,000 acres. And similarly, we estimate 100,000 acres, or 10% of the original million-acre Great Black Swamp in northwest Ohio could be converted to treatment wetlands, and perhaps is the only management option that will remove enough nutrients to save downstream Lake Erie and the Laurentian Great Lakes. We're going beyond saying it might work. We're saying it will work, and all the other ideas that we've heard probably will not. Our wetlaculture approach could produce a sustainable business approach to lessen our fertilizer excesses in many parts of the world while enhancing the global extent of wetlands. Farmers and investors could make a profit either by farming or creating wetlands, and downstream waters will be cleaner too. And then my final statement I always give in my talks is wetland restoration and creation are not easy. If they were, everybody would be doing it. They require attention to Mother Nature. That means Mother Nature's in charge of self-designing these systems. We're not gardening. Even though I'm here at the Naples Botanical Garden, I have to say that softly. This is not gardening. This is ecological succession. And Father Time. These projects take time to reach their potential. Our research team in Naples, I've been using this photo for a couple years now. I better get a new one. But no, we just have a great crowd of people at our lab all the time. Graduate students, visiting scientists, somebody who's just walked off the street, we grab them and put them in this picture. Advisory committee that we have that are very active. And Lee, of course, in the lower right. But it's just a great team, and I love working here, and I think we're going to try to fix the planet. If you also want to fix the planet, you can help me by buying my book. No, it's a 5th edition of Wetlands, and there was a flyer that I just got from the publisher, John Wiley, like earlier today, and I put it in the back of your pamphlet, if you can find it. And they're giving you a just you guys, 20% discount on the book if you order with a secret code. I didn't know they had secret codes anymore. And again, not everything, the wetlaculture is not in this book because that's a relatively new idea, but a lot of the stuff I talked about, the Great Lakes, the Everglades and so on, is in this book. It's fairly new at 2015. And by the way, Florida got back on the cover. When I was up in Ohio, it was always Ohio waterfowl. But when I moved down here, I said, I got to put the mangroves back on the cover of this book. So that's Naples Bay on the cover of the book. Whoops. And then I'm supposed to say thank you, and that's how you contact me. Thank you.